Hello everyone, in this video we'll be studying the preparation of aldehydes. That means only aldehydes. In the first two videos we have seen the preparation of both aldehydes and ketones from a single chemical reactions, but from now on in these preparation methods we'll be checking only the preparation methods for aldehydes. Now the first one is known as Resonance reduction. Now let's check resonance reduction. Now resonance reduction here, acyl chlorides or acid chlorides is the hydrogenated over catalyst palladium on barium sulfate. Palladium on barium sulfate. Now palladium, the catalyst here, palladium on barium sulfate. This is the catalyst here. Now this on reaction with acid chloride RC or acyl chloride on palladium on barium sulfate, we will be getting our aldehydes. Now if we check, for example here, RC double bond, this is our acyl chloride. When we on hydrogenation in palladium over catalyst palladium over barium sulfate, we'll be getting RC double bond OH. Now this is the first reaction. Now when it reacts with benzoyl chloride, this is our benzoyl chloride. Then we will be getting here this. In this way, this is known as resonance reduction when acyl chloride is hydrogenated over palladium catalyst on barium sulfate. Now in this way benzaldehyde is produced. Now let's check the second preparation methods of aldehydes, that is from nitriles. Now from nitriles, this reaction will be known as Stiffness. This will be known as Stiffness reaction. Now how does Stiffness reaction takes place? In Stiffness reaction we will be getting here nitriles are reduced to corresponding imines, first with stannous chloride in the presence of hydrochloric acid, which on hydrolysis they give the corresponding aldehyde. Means nitriles when it reacts with stannous chloride and NCl2 in the presence of hydrochloric acid, it will be converted to imines. This is known as an imines. On hydrolysis we will be getting when on hydrolysis we will be getting our aldehydes in this way. So therefore this is known as Stiffness reaction. Now let's check the chemical. Now let's take an example here. The nitriles are first reduced to imines. Now this is written. Now if we take our CH3C, this is our nitriles. Now we have SnCl2 HCl in this way. Now 2 moles of HCl are used, therefore these 2 moles of HCl can produce 2 protons in this way. Now there is when one of the bond breaks up, we will be getting CH3C double bond, one H will come and join here, and then N, this ion, the other NH will come and join here in this way. Now on hydrolysis we have here, on hydrolysis H2O. Now this is the way in which this is our imine. Now the short trick method for this reaction is, if we OH, H, these are water molecule, when this bond breaks, two bond breaks, then result in the breakage of these 2 bonds. Therefore we will be getting our CH3 C, the H is here, and this double bond, these 2 bond breaks, it will be equal, and then O will come and attach in this way, and then there will be release of NH3 3H, so NH3, therefore there will be release of ammonia. Therefore in this way aldehydes are produced from nitriles. Now if we check the reaction mechanism, where we know that reduction means addition of hydrogen. Now these are stannous chloride, we have 2 plus, now and when it gains 2 electrons, loses 4 electrons, is less than 4 plus 2e minus. Now these are CH3C triple bond, and this becomes, this is partially positive, this is partially negative. Now the 2 electrons, if it comes index here, this comes here, and then we're getting CH3C double bond, and this will be negative, and this will also be negative. Now we have here 2 H plus protons. Now the 2 H plus protons that was produced from the acid, 1 H comes here, 1 H comes here, therefore they are resulting in the formation of CH3C. 1 H will be here, and then double bond and H. Therefore this is the way in which our imine is formed, and hydrolysis will be in this way. There is breakage of bond and then attachment of the oxygen to this kind with the release of ammonia molecule. Therefore this is the reaction. This reaction is known as Stiffness reduction reaction, in which the nitriles are reduced to aldehyde, first imines and then to aldehydes, by stannous chloride in the presence of hydrochloric acid. On hydrolysis, we shall give our aldehydes.